Hello and welcome. In our previous tutorial, we'll learn about spatial references and coordinate systems, a topic totally necessary for this and the forthcoming tutorials. If you don't already have checked our previous video, the link will be down below. In this tutorial, we will learn how we can draw circles given a point and a radius, calculate the distance between 2 points, calculate the total area of a rectangle, its circumference, also its central point. Let's jump into Jupyter Notebook. Back to our Jupyter Notebook, our first task is to learn how to draw circles. We have run all the commands we need for our base map. Let's create our first point. Run the command. Now from arcgis.geometry.functions import buffer. Create a new variable called ptBuffer equal to buffer parentheses geometries equal to a list. Inside the list our point. It doesn't have to be just one point. Input spatial reference equal to 4326 geographic coordinates, the same as our input point. The distance equal to 10,000, also the unit 9001 as a string, which stands for meters. Run the command and let's draw them on our map. Going back to our map, let's zoom in. You can see we have our pin in the middle, also the circle around it. To see the ptBuffer in more details, let's print ptBuffer, run the command. You can see that it is a list, inside the list a dictionary, which contains all the points we need to create our polygon as a circle in spatial reference well-known ID 4326, which stands for geographic coordinates. We need only the first element of our total list, so we use the 0 index. Run the command and we have our circle. Let's continue by calculating distances. From arcgis.geometry, let's import distance, run the command, create our second point, also in well-known ID 4326, and let's create a pt distance variable equal to distance, spatial reference 3857, geometry 1 our first point, geometry 2 our second point, and we want to calculate this distance in unit 9001 in meters. Let's print also the distance. You can see that it is 1.4. Run our map. From arcgis.geometry import polyline and let's create a line that connects those 2 points. Run the command and let's draw them on our map. As you can see, our total distance is not just 1.4 meters. The reason why is that we use projected coordinates to calculate our total distance, and we use geographic coordinates for our points. We can solve this issue by projecting our points in projected coordinates. For this we use the project module from arcgis.geometry. Our pt variable equal to project, parentheses, geometries equal to a list. Inside the list our first point, input spatial reference 4326 our geographic coordinates, and output spatial reference 3857 our projected coordinates. Again, the return is a list. We need the first element. That's why we use the 0 index. The same for pt2. Run the command. You can see our well-known ID has changed. Also, the x and y coordinates has also changed. Going back to calculate our distance, run again the command. Our total distance is 179 kilometers, which is total correct. Let's continue by calculating area. We'll create a third variable, also projected in projected coordinates, run our map, and draw the 3 points on our map. We will create a polyline that connects those 3 points, also draw them on our map. Now from arcgis.geometry, we will import polygon, also create a new variable called plg that contains our polygon, Given those 3 points, run the command. We will clear the graphics, also draw the polygon. We want to calculate this shaded area. We can easily do this by using PLG, which stands for polygon variable dot area, and the command. Also, we can calculate the total circumference of the polygon using plg.length, run the command. And finally, calculate the central point using plg.centroid. We will create a new variable that contains the center point. Also draw this on our map. Run the command. Going back to our map, let's zoom in. You can see our rectangle and its central point. That's all for this tutorial. Thank you for watching and see you in the next video.